Hi children, this is the third video of the topic integration. To watch more educational videos, please subscribe my channel. In this video, we are going to focus our attention on area between two curves. Our first question is to find the area between the curves y equals to minus 2x squared plus 4x and the line y equals to 3 over 2 as shown in the diagram. Initially, we need to find out the intersections between the two curves. That is much important when you are doing such question. From this example, we can understand that the x-coordinates where the two curves meet each other are 1 over 2 or 0.5 and 3 over 2 or 1.5. If you want to obtain the required area R, we can get it by subtracting area 2 out of subtracting area 1 as shown in the diagram. If you want to find the area 1, you can say that there is an area between the x-axis and the curve minus 2x squared plus 4x in between 1.5 to 0.5. If you refer to the initial diagram, you can understand this much clearly. If you use the usual integration formats, you receive the answer 11 over 6. To understand how to obtain these integration answers, please refer Beginners to Integration Part 1, Part 2. With the same time, if you want to obtain the area of the second shape, area 2A2, we know that that's a straight line of y equals to 3 over 2. Therefore, if you want to obtain this area, you can integrate the line 3 over 2 from 1.5 to 0.5. There you get the answer 3 over 2. Or there is another point where we can understand that it's a rectangle. The height of the rectangle or the width of the rectangle is 3 over 2 and the length is, that is the length between the x-coordinates 1.5 to 0.5. With that also you can obtain the answer 3 over 2. You can use any method, preferably easier for you. Then after that, if you want to obtain the required region R, you can subtract the area 2 out of area 1. Therefore, you can subtract 3 over 2 out of 11 over 6. You will be receiving the answer 1 over 3. Hopefully you understood how to obtain this region R. This is our second example. In this question also, we need to find the area R as shown in the diagram. From this diagram, you can understand that if you want to find the required area R, you can obtain the area A and you can add the area of the triangle A2. From A, if you make a division, vertical division, you can understand that it's split into two areas, A1 and A2. By adding these two areas, you can obtain the required area R. How to obtain the area 1? You can understand that if you integrate the curve x cubed minus 8x squared plus 20x from 0 to 2. First you draw the diagram, then it will be easier for you to understand this question. You will obtain the area A1. If you use a usual integration, you can obtain the answer 68 over 3. Then after that, if you want to find the area 2, it's a triangle. Area of a triangle you can obtain by the formula half base into perpendicular height. Therefore, the base is the difference between the coordinates 2 and 10 over 3. And the height, how do you find the value for height? If you substitute the x-coordinate 2 into the curve y equals to x cubed minus 8x squared plus 20x, you get the y coordinate at x equals to 2. That would be the exact height of the triangle which is related to area 2. So if you substitute 2 into y, you'll be obtaining the value of 16. That would be the perpendicular height for this triangle. With that, if you apply half base into perpendicular height, you obtain the area 32 over 3. Then to obtain the region R, you can add area 1 and area 2 as shown in the previous diagram. With that, you obtain the final answer as 100/3. This is another very important question to find the area. So you can observe from this diagram one area from 0 to 1, that is above x-axis, and the other area is area enclosed by the curve and the x-axis from 1 to 2. From our previous theories, we know that if you obtain the areas above x-axis, you will obtain a positive answer, and area below x-axis you can obtain a negative answer. If you want to find the area over here, you cannot straightforward integrate it from 0 to 2. The reason is that if you integrate it from 0 to 2 straightforward, this positive area and negative area get cancels and you will obtain a resultant value. But that is not the exact thing we need to find out. You need to find the area from 0 to 1 separately and area from 1 to 2 separately, and you have to add them together. That is the way of doing such question if particular areas were above x-axis and some other areas were below x-axis. Then I am going to obtain this area by adding area 1 into area 2. Let's see from next slide how to obtain this area 1 and area 2. To obtain the area 1, you can integrate the curve x times of x minus 1 into x minus 5 from 0 to 1. That is the first part of the area. But from our previous theories, we know that we cannot obtain this area straightforward. Initially, you have to expand the brackets x into x minus 1 into x minus 5. Then you can do the integration. Therefore, if you expand these brackets, you will obtain the answer x cube minus 6x squared plus 5x. You can integrate it from 0 to 1. If you do this integration and substitute the boundaries 0 to 1, you will obtain the answer 3/4. So you can say that this is a reasonable value. Since it is above x-axis, you should get a positive answer. If you want to obtain the area 2, you can integrate the same curve from 2 to 1. If you follow up the steps, you can obtain the answer minus 11/4. What is the reason for us to obtain a negative value? As I mentioned in previous, we can understand that this area is below x-axis. Areas enclosed by the curve and x-axis, where the curve is below x-axis, definitely will obtain a negative answer. Such situations, what we need to do is we have to obtain only the value, or that is called the magnitude of the value, when add those figures to obtain the final area of this kind of a shape. Then you can obtain the final answer by adding area 1 into area 2, that is 3/4 plus 11/4. You will obtain the final answer as 7/2. Hopefully you have a better idea how to find the area between curves. If you like this video, please put a big thumbs up and please subscribe my channel. Thank you.